Have you ever wondered about the pencil you've used since childhood? It's made of wood, but how is the black lead inserted inside? Or consider car airbags that save thousands of lives daily. How do they inflate so quickly during accidents? And most intriguingly, when and why was the first airbag in history created? Welcome back, viewers. In life, we use many things whose benefits we know, but few of us understand the effort and techniques behind their creation. Let's explore the manufacturing process of 5 everyday products we commonly use. The first airbag concept came to an industrial engineer in 1950 during a family trip. After surviving an accident, this incident inspired him to invent the airbag. After 2 years, he created an airbag that filled with compressed air cylinders, but the process was too slow for accidents when time is critical. This issue remained unsolved for years. Then in 1967, an American engineer had an idea: fill airbags with gas from a chemical explosive. The airbag contains sodium azide, which receives an electrical signal from the car's crash sensor during an accident. This signal triggers a chemical reaction, releasing nitrogen gas that instantly inflates the airbag. From the moment of the crash to the inflation of the airbag, it only takes 20 milliseconds. Which is as quick as blinking an eye. The airbag can inflate 5 times in that duration. The material of the airbag is also unique, made in one entire piece. This fabric is significantly thicker than others, constructed using 1,000 nylon strands at once. If even a single strand breaks during this process, the sensor forces the machine to shut down immediately. Despite the machine operating quickly, it only produces 8 meters of fabric per hour. The material is made on one end and simultaneously wound on the other. Once this process is complete, the fabric is washed, passed over heated rollers to dry, and then pressed. Gas pressure builds up inside the airbag, requiring a silicone coating to ensure it remains airtight. Computerized rollers spread silicone evenly on the fabric. It's then passed through large vents to dry thoroughly. Next, airbags of various shapes and sizes are cut using computer-operated machines. After final inspection, the airbags are stitched and then tested. Now, let's talk about aluminum foil. Aluminum foil is so thin that even slight pressure can tear it. But have you ever wondered how heavy aluminum blocks become such thin sheets? First, small pieces of pure aluminum called ingots are melted in a furnace. Melting 2,700 kilograms of aluminum takes 8 hours. The molten aluminum is then filtered and purified before being poured into a mold and cooled to form a specific shape. Each aluminum block weighs 3.5 tons and is lifted by a crane onto a milling machine. The machine has heated rollers that gradually flatten the aluminum block. After each pass, the rollers move closer together. Remarkably, the 45 centimeters thick block is reduced to just 5 centimeters after only 15 passes through the machine. After this, the 5 centimeter sheet is milled to foil thickness. The aluminum foil becomes so thin its edges get damaged. A cutter blade then cuts it to size and trims the damaged edges. At the machine's other end, finished aluminum foil rolls are wound, now ready for use. Now let's learn about the manufacturing process of bulletproof glass. A 9mm bullet is so powerful it can pierce through a thick steel plate. So why can't it penetrate bulletproof glass? What's special about bulletproof glass that stops bullets? First, a normal glass is bent in an oven, since bent glass is stronger than a straight one. Afterwards, 4 bent glasses are stacked with a PVB sheet sandwiched between them. This special sheet not only holds the glasses together but also hardens them. The edges of this stack of 4 bent glasses and 3 PVB sheets are then sealed with tape, and a plastic sheet is securely overlaid and sealed. Air is then extracted from under the plastic using a vacuum pump, and the setup is placed in a large container. The pressure inside this container is 10 times that of our atmosphere, and it is heated to 278 degrees Celsius. This heat and pressure bind the PVB and glass together, initially 4 glass sheets and 3 PVB sheets, into a solid unit referred to as single-sheet bulletproof glass. If this bulletproof glass is tested with a 9mm bullet, the exterior layers dissipate the bullet's energy across the glass, while the middle PVB sheet stops the bullet before it reaches the final glass layer. Now, let's talk about pencils, often called lead pencils. Actually, they don't contain lead, but graphite, which leaves a black mark on paper. The first pencil was made in 1630. Since graphite and lead look similar, people thought pencils contained lead. This confusion cleared up in 1789, but many still call them lead pencils today. Just as the pencil's history is fascinating, so is its manufacturing process. First, a mixture of graphite and clay is made. When soft, this clay is pressed through lead-sized holes. This machine produces identical-sized leads. These leads are then baked to solidify. The process for color pencils is similar, but uses color instead of graphite. That's why color pencil leads are thicker, as they're more fragile. After making the leads, it's time to create the pencils. On 10 mm wooden sheets, machine-cut grooves are made to fit lead. Glue is applied to these grooves. Leads are inserted and another sheet is placed on top. These sandwiched sheets are then dried in a large wheel to ensure the leads and wood bond strongly. After drying, the sheets are sent to the milling machine. The milling machine cuts the sandwich into various pencil shapes. They're then colored, stamped and quality checked, including lead stress tests. Finally, they're sharpened and packed. Now, let's discuss an essential part of our daily lives: sugar. The science behind turning sugarcane juice into pure white sugar crystals is fascinating. First, sugarcane is transported to the mill by trucks, where it's cut and thoroughly washed. Then the sugarcane is crushed using a crusher, and the juice is extracted. This sugarcane juice still contains many impurities like soil, stones, or sand particles. Now it's time to filter it. For this, the juice is boiled and it is mixed in the solution of lime. After mixing for 6 hours, the color of the juice becomes yellow from brown, and during this time its pH level also becomes normal. Now, this clean juice is taken out, while the waste that is left is not any garbage, but it is used as fertilizer. The juice now goes into big boilers where it is boiled so much that water evaporates from the juice, and this type of thick paste is left behind. If given, it becomes jaggery, but to remove white crystals of sugar from this, a solution of sucrose is added to it, which binds sugar, and then it is put in another machine. In the same way, this machine also works. This process is called centrifuge. When the sugar paste is rotated at high RPM, the remaining water comes out of the holes of the tub, while the white crystals of sugar are stored inside the tub. But the humidity in these sugar crystals is still very high. Because of this, it is passed through hot air to dry, due to which the humidity level of sugar drops. Now sugar is all ready for packing. With the help of packing machine, more than 2 lakh packets can be made in a day. How did you like today's topic? Definitely tell me about it in the comments section. Hopefully, you guys will also like and share this video. Thank you very much for your loving comments. See you in the great video.